Hello folks, today I'm going to share with you my thoughts on the GL.iNet's new Remote KVM product, the Comet. This product is an open source remote keyboard, video, mouse unit that works over the network. The Comet is designed for the management of computer servers where you can deal with boot failures, adjust the BIOS UEFI settings, and also perform file transfers, all done remotely. And when I say remotely, I mean either down the hall from the server room or on the beach where you are working from home. And the disclaimer before we get to the review is that I got the product from the company for evaluation. I am not getting paid for this review. The company is not influencing the review, and all of the opinions expressed in this video are my own. The first question some viewers may have is, what exactly is a Remote KVM? And why do I need one? Well, a Remote KVM is a device that allows you to control a computer from anywhere that has an internet connection. You can remotely control an office server from home or your home lab while you're on vacation. So how does this differ from something like remote desktop software? Well, for a software connection to work, the remote system must be on and be able to accept the protocol requests such as RDP, VNC, or SSH. With Remote KVM hardware, your remote system could be off, and by using the Comet with accessories, you can remotely power on your system and then see it boot up via a browser. You can then see boot failures and rectify the problems by adjusting BIOS or UEFI settings. Okay, so let's break this bad boy out of the box. Well, it looks like the box contains another box which holds the actual unit. In the outer box, we have a HDMI cable, a USB-C to USB-C cable. The smaller box contains paperwork like a quick start guide, and then an invite to join their community for customer support, product updates, firmware updates, etc. The Comet itself has a nice metal case, not cheap plastic. That's probably more for heat distribution than anything else, as the unit gets a little bit warm. It has a restart button on the right-hand side. On the upper side, there is a USB-A port, an HDMI port, and a USB-C port meant to be connected to the keyboard and mouse ports of the remote system, as indicated by the icons. On the left side, there is a USB-C port for power and an Ethernet RJ45 port. And the natural question on whether this is a power over Ethernet unit, and the answer is sadly no.
Failure!
You need to separately supply power via that USB-C port. On the bottom of the unit is the device ID. We'll need this in the future. And then the other cables in the smaller box is an Ethernet cable and a USB-C to USB-A cable. The size of the Comet is a bit smaller than that of a standard 2.5-inch SSD, but twice as thick. For those who are not complete nerds and don't have any idea what a 2.5-inch SSD looks like, I will compare it to a standard deck of playing cards. So the Comet is just a little bit smaller in size, but just about as thick. If you look at the device from top down with the GL.iNet logo on top, the left side has an Ethernet port that you need to connect to your local network. The Type-C power port needs to be connected to a power source. On top of the Comet are 3 ports. Connect the USB-A port to the ATX card or other accessories like the fingerbot. Connect the HDMI in port of the Comet to the HDMI out port of the system that you want to control. Connect the USB-C port on the upper side of the Comet to the USB device ports of the system that you want to control so that the Comet can send keyboard and mouse commands to that system. If the device being controlled and the controller are on the same network, you can just open up a browser on your controlling system to access the Comet. Enter the URL of glkvm.local or the IP address of the Comet in the browser, and it will take you to that page. If the device being controlled and the controller are not on the same network, you will need to install the GL.KVM app on your controlling device. The app comes in a version for Windows and one for Mac OS. As you get past the self-signed certificates of the Comet, you will see that the Comet is not only based on Pi KVM, they also use the same certificates, and they're listed as being out of Russia. So that's a little bit interesting. We'll circle back to that. Next, you will see that because it's our first time logging in, you are forced to set the admin password. So that's good security practice instead of leaving it with some default password. And once I type in the same password twice, then we're going to be presented with the web interface to the Comet. So once I get connected and I can see the Comet, the first thing I would do is update the firmware. The latest version as of this video is version 1.1.1, which is dated April 23rd, 2025. And you can download that from the GL.iNet website, or you can basically use the controller here in the web page to do that. And I have seen from other reviewers who got this product before this version of firmware that they experience a lot of issues. So I highly recommend you update the latest firmware to avoid any problems. Let's start at the top right and go to the left. The first item is logout, and then next to it is reboot. Those are pretty much self-explanatory on what they do. Next is security, where they allow you to change the admin password and then also set up a two-factor authentication code. What this is going to do is create a QR code for you to scan into the Authenticator app, or else you can just type in that text code. So it's a nice security feature, especially if you're going to be going through the internet to manage your computers. Next is the cloud service, where you need to download the client onto your controlling computer so that you can manage your computers from the internet. This app is available on the Mac OS and Windows platforms. No Linux. Next item over is the firmware version, and if it's not up to date, it will let you update it here. Then comes the full screen mode, where your browser window will take over the whole screen. And lastly, the collapse toolbar button. You can expand the toolbar back by clicking on the downwards arrow at the top center of the window. For the rest of the menus, I'm going to go from the left to right, starting with settings. Note that having the settings menu opening will reduce the size of the screen to see the remote system. The first section is the video quality. You can choose from low, medium, high, and ultra high. Choosing low will get me about 600 kilobits of transfer. Choosing medium, the bitrate now is about 2000 kilobits per second. Going high pushes the bitrate up to about 3500 kilobits per second. And finally, choosing ultra high, the bitrate goes to about 5000 kilobits per second. Next is orientation, where you can rotate the display of the remote system by 90, 180, or 270 degrees. I am not sure what the application for that would be, but I'm guessing that they have somebody asking for it. And the third thing one can change is the EDID, or Extended Display Identification Data. For the most part, the Comet KVM aims to automatically adjust the display output to present the best picture by reading this EDID of the display. I assume that the Comet is smarter than me, so I'm just going to leave it at something I can see, like 1920 by 1080. I noticed that when I switch the EDID to a higher resolution, like 2560 by 1440, my remote computer will assume that since the external monitor has a better resolution than the primary monitor, it will get itself off the mirror mode, and then the Comet display will have the higher resolution. The issue I found with this is that now I lost the ability to get to the menus from my remote system, so I can't launch any GUI tools and I'm stuck with the terminal window. I also found that my remote mouse is now not in sync with the one from the controlling system. As you can tell here, they are actually pretty far apart. The next section is the remote device settings. The manual says that the audio setting will turn off audio on the remote system, but I was not able to get this to work. Audio from YouTube kept playing on the remote system regardless of the setting of the toggle switch. You can choose to pass along the mouse and/or keyboard as well. By default, both are set as passing, Otherwise, it kind of defeats the purpose of a KVM. Show virtual keyboard will pull up an on-screen keyboard, will allow you to type into the remote system in case your regular keyboard doesn't have special keys like F1, F2, etc. One thing that I could not figure out is how to type a sequence of keys like Alt F4. I did figure out that I can use the virtual keyboard to hold down the control key while I use my real keyboard to type in like the letter C to get Control C. And lastly, the show local cursor allow you to turn off the location of the local cursor. This may seem useless as most of the time the local cursor and the remote cursor are in the same place. But like I mentioned earlier, in some display modes, the local and remote cursors don't line up and the local cursor is pointing to the wrong place. So you can turn off show local cursor to only see the cursor that matters. The last section allows you to choose system settings like language of the interface. You only get to choose between English and Chinese for now. And then you can also choose dark mode or light mode. And lastly, you can reset the Comet KVM. Note that this is a hard reset that will erase all configuration info, but apparently it still bounds to your account. So not quite a hard reset if that's the case, but I didn't actually try it out, so I don't know. Next item on the top menu bar is the toolbox. With the toolbox, you can type or paste text into the clipboard, which can then be used to paste to the remote device. This is kind of cool, as you can paste parts of scripts for performing sysadmin tasks on a remote system. So for this example, I'm just going to have part of a mounting script here and doing some backups. I can just click on the paste to remote device and look at that. It gets pasted right into the remote system. Very cool. And there are shortcuts that you can use to control the remote system. And if you want to see all of these beyond the top 4, you can click on the All button over here. As I mentioned earlier, the virtual keyboard doesn't seem to allow holding down multiple keys at the same time. So this section provides some of the more commonly used combos. So I'm going to go ahead and open up a new terminal window here, and then I'm going to use Alt and then F4 to close that window. All right, you can also add devices to the Wake on LAN section so that the Comet can be used to wake up or power on devices that are in a low power state. But you have to make sure that the remote devices is set up for Wake on LAN. So make sure you make those changes on the remote systems first. Lastly, there is the terminal. Once you hit the access button, we get a new browser window that's a shell window on the Comet itself. And looks like the Comet is running Linux. Not a shocker there. For the USB-A port on the top side of the Comet, you can plug in accessories such as the ATX card or the fingerbot. The ATX card can remotely control a system's power supply by simulating the operations of the physical power button. And the fingerbot can also control a remote system's power button by a physical robotic button that you attach to the computer's power button. Yeah, that sounds pretty cool, but too bad it's not available for testing yet. So I decided to plug a thumb drive into that USB-A port to see what happens. The accessories menu item still states that there is no external device, but if I get into the command line, that device is actually listed as /dev SDA, and all the partitions are auto-mounted so that we can access the data on that USB. So I'm going to do a df-h. You can see that there's 2 partitions on here and they are both mounted. So we can take a look at the contents just so you know that the auto mount is on and you can get files off the thumb drives. So I'm going to do ls/media/usb0/media/usb1. And here are the respective files in those 2 partitions. Next, we have the virtual media menu. Here we see that there is about 5.7 gigs of space on the Comet that we can upload data to. Then we can mount that to the remote machine, meaning if we upload a bootable ISO, then we can have the remote machine boot to the ISO. I'm going to upload the Arch Linux ISO, which is only about 1 gig. but this device is running really slow at about 5.5 megs a second. So it's going to take about 4 minutes or so. So I'm going to go ahead and speed this up for your viewing pleasure. And I will also upload a PNG file just to demo the file sharing capability. All right, once I've clicked on the Mount to Remote button, I have a choice of file sharing with a remote system or image mounting. Let's explore the file sharing first. So apparently this emulates a read-write USB drive, and the steps is that you look for the mounted device on your Windows PC, open the device named drive-GL-KVM, then do what you need with the mounted USB. But just make sure that you eject it when you're done. All right, now I'm going to choose the other option of image mounting. So what this does is I can mount this as a CD-ROM. So I select the ISO, and then continue, and then I select mount image. And I'll get a screen that tells me it's emulating a CD-ROM, and it supports BIOS UEFI boot for system reinstall or ISO-based software installation. Okay, I'm going to go ahead and reboot the remote system via the Linux OS menu, and we'll see if it boots to the CD-ROM image. So since I'm running this on a laptop, which does not send its BIOS screen to the HDMI interface, we will only see the boot process once we get to the point where the display drivers are loaded. So it looks like the screen is frozen for a while. But as you can see here, it's actually working, right? We actually have successfully booted to the ISO that is on the Comet. But the terminal font is kind of tiny, so let's change it to something more legible. I'm going to do set font, Sun 12 by 22. Now to prove to myself that I just booted my remote laptop to the Arch image, I'm going to take a look at the hardware. So I'm going to do DMI decode -s system-product-name. And sure enough, we see that we're running off the ISO that's loaded to the Comet KVM, which is acting like a CD-ROM to the HP Stream laptop. That's pretty cool. And before we leave this section, make sure you clean up by shutting down the computer and then stopping the mounting on the Comet KVM so we don't keep booting back into the ISO. And we'll do that by doing reboot now. The next menu item is the Apps Center. Looks like for now there is only one app, which is the Tailscale VPN. Turning this app on will let you bind this device to your Tailscale account. And once you do that, you can remotely access the Comet by typing its Tailscale virtual IP into a web browser on the controlling device. I don't have a Tailscale account, so I'm going to save that demo for another day when I get that set up for you. The last menu item is Help. Here you can look at the version of the firmware for your Comet. You can get to the help documents from the GL.iNet website. And lastly, you can export log files. The export log file function dumps out a zip file that contains a few logs. First one is a dmessage log, which is basically the system log from the boot process onwards. The log read log, which is the syslog debuffer. And then the output of the lsusb command that shows what USB devices are connected. The memory log shows the memory stats, so I guess the developers can use it to see if they have any memory leaks. And lastly, the PS log shows the output of PS-AUXWW, so the developers know what was running and what resources it was taken up. So these may or may not be useful for the end user depending on how much time and effort you want to put into debugging this device. Let's take a look at what's under the hood of the Comet. From the Toolbox menu, I'm going to go ahead and access the terminal window on the Comet. And then I'm going to take a look at the boot log using the dmessage command, which I'm going to pipe through less. So here we see that the Comet is running kernel version 4.19.11, which seems a little dated as that's from the 2020 time frame. Moving on, we see that it's using the ARM chip version 7, which may explain the older kernel as that chip is even older. But I guess that's why the Comet can be had for less than $100. Scrolling down, we get to the memory section, and it looks like there is 1 gig of memory available. And then I'm going to keep scrolling past all the other stuff that is probably not of interest for now. And here I see something about WireGuard. That's probably a hint that the VPN capability is available. I'm going to keep scrolling, and I see this section about MMC0, which is the internal storage, and it looks like there is 8 gigabytes of space, which is sliced up into 10 partitions. And I'm going to keep going until I get to right around here. I see that there is some references to Wi-Fi, and I also saw some Bluetooth earlier. So maybe there's Wi-Fi available in the near future. Who knows? All right, that's about all that the boot log is going to show us. So let's go back into looking at the internal storage. That 8 gigs of space that was partitioned into 10 partitions. I'm going to go ahead and do a df-h to see what's there. And here we see partitions 7, 8, and 10 of the MMC mounted. Partition 8 is the 1 gig or so space that's available to the user, right, just for general space. Partition 10 is the 5.7 or 5.8 gigs or so under the virtual media section. So that's available for you to upload an ISO if you want to remotely boot the computer off that, or you can put files on there for file sharing. All right, let's see if we can get more info about networking. I'm going to do ifconfig-a, and here we see the Ethernet, right? We've got an IP assigned and all that. That looks normal. We've got the loopback port. That's normal. But then we also see USB 0. So it looks like we have another possibility for another network tap on this thing. I'm not sure what that is for now, but that's interesting anyways. And when we were looking through the D message, we saw some reference to Wi-Fi. So I'm going to do an iwconfig, which doesn't give us anything. Again, maybe for future expansion. I'm going to do a WL radio, and it looks like the command is available, but the driver is not found. All right, the last thing I'm going to look at is what ports are open. So I'm going to do an nmap of 192.168.1.151, which is this machine. And looks like nmap is not available on this machine. All right, so let's try using netstat. I'm going to do netstat-lnp capital W. Okay, so for TCP protocol, I see that it's running the Nginx web server on ports 80 and 443 for HTTP and HTTPS respectively, which makes sense as we control the Comet via the web interface. I also see the conman daemon running off port 53 for DHCP, so I guess that's how I can type GL.KVM.local into the browser and be pointed to the Comet. And lastly, I see the dropbear SSH server running off port 22, which is probably how I got this connection to the terminal. Then for UDP, we've got a bunch of stuff listening off port 5353, like the Avahi daemon for multicast DNS, and it looks like it's running off other ports as well. Then we got the JNIS web RTC server running. And lastly, we have the network time protocol daemon running off port 123. So that's probably enough of a sneak peek for now into the Comet's hardware. We can explore deeper in a future video if people are interested. Overall, the Comet delivers as a remote KVM in a small form factor with a good price. It allows one to remotely control a computer from any other network connected computer. And when I say control, I mean fully control from the initial boot up of the machine where you can make changes to the BIOS. This is not just a remote terminal that you can log in after the operating system has been fully loaded. There is no software to load on the remote computer or local computer if you want to just use the web interface. Loading the app onto the controlling computer will allow you to control multiple computers from the app. The app is available on the Windows and Mac platforms only. Firmware that was used in this video is a huge improvement over prior versions, but there are still more kinks to work out. Improvements over the speed to write to the internal storage would make the virtual media feature much more appealing to upload various OSs for remote booting. And then power over Ethernet would be another big improvement to eliminate having to separately power the units. For another video on networking, watch this video here. For more networking videos, make sure you click on the blue monkey to subscribe. Thanks for your time and happy hunting.